We'd now like to turn our microphone actually over to some of these partners who have experience with the CLiCC program. First is Dr. Rich Helling. Dr. Rich Helling is the Director of Sustainable Chemistry for the Dow Chemical Company. For 30 years, he's worked in research and development, manufacturing and sustainability, and now he leads Dow's use of life cycle assessment and other sustainability metrics.
Thanks to UCSB and to the CLiCC team for undertaking and advancing this ambitious and very exciting project. I personally have greatly enjoyed and benefited from my interactions with the project team over these past years. My perspective is really that of a life cycle analyst, one who has a strong interest in estimating life cycle inventories and life cycle impacts of materials. In particular, I'm often involved with developing life cycle assessments for products that we produce that have many material inputs. Some of them we make and some of them we purchase. And so I have a strong interest in the cradle to gate life cycle impacts for materials that we purchase, especially those that may not be in existing databases. And this happens a lot. The methods used by the CLiCC team evolved over the course of this project as they got input from the advisory board. And I think they've ended up with an approach for the life cycle impacts that is both very reasonable and very useful. This part of the CLiCC tool was in part developed on the depth of information in Ullman's Encyclopedia of Industrial Chemistry. I know they used other sources, but that as an example just reflects the breadth of the chemistries that are included in the tool and that was used to develop the neural networks and the correlations to come up with the life cycle impacts. And the tool has provided me with what I think are reasonable estimates for carbon footprints and energy demands for a variety of materials. As a specific example, during some recent tests, I used the CLiCC tool to improve selections of material models in my work. So I generated estimates using the tool for the carbon footprints and the cumulative energy demand, in particular for a couple of functional ingredients in a formulation, which were quite different. So I also estimated what those in turn were made from, since I didn't have those completely in other sources either. Some were in Ecolab, but not all. So I needed to have other sources of information to come up with estimates for them. The CLiCC results, and in particular, the data quality indicators really helped me select the best quality inputs or to put some more effort in the lower quality ones. So those data quality indicators are really important to understanding the output of any software tool, but in particular, one that we're using to do for life cycle assessments. As a side note, during these tests, I also found the online videos were helpful in getting me started in using the current implementation of the tool. I wouldn't yet use the tool for comparisons or absolute statements related to the toxicity-related metrics, particularly those that go beyond acute toxicity, as there are not accepted, I think, QSAR methods for all of these. And this is really still a field that I think needs more human expertise, judgment, and data. But similar to toxicity metrics in LCA, otherwise, the tool can be used as a way to flag something that needs further investigation, potential hotspots or issues that you really need to dig into a little bit more. So in summary, for me, CLiCC today is a very useful tool and a great addition to the LCA toolbox for the life cycle inventories and impacts and estimation of these well-established life cycle impact categories. So Elise, back to you.
Thanks so much, Dr. Helling. Next, we'll hear from Dr. Xiaoying Zhou. Dr. Xiaoying Zhou is a senior hazardous substances engineer with the Department of Toxic Substance Control at California EPA's Safer Consumer Products Program.
Good morning to all the web attendees, and thank you everyone for making this happen. And this is a terrific event, and congratulations again to the team for the launching of the CLiCC tool. And back to 2014, the Brand School and DTSC started to collaborate on a project to explore and develop the potential synergies between the CLiCC2 development and the Safer Consumer Products Program. So I need to, bear with me, I catch a cold. And so I need to throw a little bit more context here. The California Safer Consumer Products Program intends to promote safer alternatives for hazardous ingredients in consumer products sold in California. So manufacturers must go through alternative analysis to compare the chemical of the concern in priority products with its potential alternatives, which could be a chemical-to-chemical replacement or reformulations or material change, or could be process or product redesign. And under the California's this alternative analysis framework, a very broad range of factors need to be considered comprehensively to avoid burden shifting between different adverse human health and environmental impacts and their interaction with the different exposure pathways and life cycle stages. But performing a full risk assessment and life cycle assessment usually requires significant expertise and resources, which may not be available to many small and medium-sized companies. So one of the major goals of this earlier partnership was to develop a streamlined and screening-level risk-based tool with a life cycle perspective, which could be used to fit the needs of the alternative analysis. And also in our framework, we regulate the product chemical combination, so not just the chemical itself. So this tool needed to be also product focused, meaning the chemicals analyzed by this tool could be linked back to specific product relevant applications and end-of-life release modules. And in addition, historically, the alternative assessment only used for the comparison of the existing chemicals, but during our partnership, we also want to, the CLiCC2 initial design could also include alternative assessment use scenarios to promote safe by design innovations at very early stages of the new chemical and product development. And so a little bit fast forward here, and last week here in Sacramento, we just had this second international alternative assessment symposium to discuss what are challenges and needs for the alternative assessment and adoptions of the safer substitutions. So one of the biggest challenges we are facing in this area is data availability and quality issues, particularly in the areas of the toxicological data, especially ecological hazards and exposure data, product ingredients and chemical use information, and the life cycle related information. And also everyone in this AA community acknowledges the uncertainty is one integral part of the AA process to inform decisions. And because this CLiCC2 has this major feature by bridging the existing data and the tools applied in traditional fields of the life cycle assessment, risk assessment, chemical process engineering, and with the recent research development of the computational tools and the predictive techniques. So that's really helped to address those data gaps issues to some extent. And in addition, it incorporates the uncertainty analysis in the results to allow us to get a better pictures of what is most important parameter or properties we should focus on. And so we can see this CLiCC2 has a lot of the potentials to to help address the data gap issues, and while providing some insights about the nature and the amount of the uncertainties involved in the AA process. So hopefully we can see more case studies and real world examples to apply this CLiCC tool to alternative assessment and alternative analysis, and see how this tool progresses. So thank you again for the opportunities to share those comments. And I find that I need to just insert a little bit a disclaimer, and those comments only reflect my own personal opinion, not representing the agency's policy position and formal interpretation of the regulations. So back to Alice. Thank you.
Thank you so much, Xiaoying. Next, we'll hear from Doug Mazeffa. Doug Mazeffa is the Product Sustainability Manager for the Sherwin-Williams Company. He oversees the company's sustainability and product safety programs. Doug has extensive expertise in the development and publication of product category rules, lifecycle assessments, environmental product declarations, and other sustainability standards. Doug?
Thank you very much. And, want to join my colleagues in congratulating the CLiCC team on some great achievements, and appreciate the opportunity to speak today. And so we've been involved with the CLiCC program since, I believe, early 2015, and actually had done a rather complex case study kind of throughout 2015, and have done some work in the interim until the launch now. And really the interest with CLiCC, we were initially connected actually through a supplier of ours, is that, we're getting a lot of push. So most folks know Sherwin-Williams is a paint company, but, truth be told, although that's a big part of our portfolio, we do all types of coatings, whether it's for, the touch screen of your cell phone to the inside of Coca-Cola cans or what have you. But on the building kind of architectural front, there's been a big push towards product transparency in terms of hazard and environmental product declarations, so sort of an LCA of products. And so on the hazard piece, a lot of the programs that are out there on the voluntary front have been more kind of fixating on raw material hazards. And, when you're making a reactive product, that as soon as you start mixing raw materials, some of those materials cease to be what they once were and kind of react and become something else, or become encapsulated or bound in a polymeric matrix, whatever that might be. It's sometimes you focus maybe too much on an SDS or something like that, and you want to understand better what's happening to your product, how folks can be exposed to it, how things degrade, what the fate and transport is. And so CLiCC really represented an opportunity to, marry some of the life cycle assessment concepts along with, the more kind of conventional hazard assessments with fate and transport and exposure assessments. So, we could go in and, look at this sort of holistically. And I really want to stress that marrying, because, so much of what's been done has maybe not looked at life cycle thinking in a broad sense. And so you can have some, kind of unintended consequences or burden shifting if you go from, product A to product B, or material A to material B, if you don't consider things like functionality. If you need a gallon of this product versus 5 gallons of the other product, that should come into play. Or if this degrades into some very, undesirable things, whereas the other one does not, these sorts of things should be tracked, and CLiCC can really help doing that, or help do that. And, controlling some of the assumptions, whether it's on the LCI side or on some of the fate and transport side, we might have products that are earmarked for, your garage floor versus a factory or something, and things like air exchange rate, occupancy, all those variables change. And so having the ability for a company who manufactures a wide variety of products to be able to, control some of those data points, since we have the data, is just a tremendous benefit. And on the lifecycle inventory side, I think last time I checked, we have something like 10,000 raw material suppliers. And so, there are inventories available commercially or from some of those suppliers that are great for our environmental product declarations. but oftentimes a lot of the additives, or if there's novel chemicals that we're using for a product, there's not going to be any data available. And so having that predictive inventory capability really could be a game changer for us, because you can use analogs. There's kind of clever ways you can get around it, but you don't always feel good about that. And so something, with CLiCC's kind of rigor and kind of capability and kind of machine learning capabilities could really be huge. So, we're, really excited to see what the future holds for CLiCC, certainly hoping to stay involved with it. It just the one-stop shopping of the kind of toxicological piece, the hazard piece with the LCA piece, as well as kind of being able to look at those life cycle thinking sort of principles, really just see a lot of possibilities here for our products, and just in terms of how we understand and communicate, the potential impacts and benefits of what we're manufacturing. So with that, thank you again, and I'll hand it back over to Elise.
Thanks so much, Doug. We have one more partner speaker to hear from today, Dr. Lynne Olson. Dr. Lynne Olson is a corporate scientist for global sustainability at Ecolab. Dr. Olson helps drive top-line growth for Ecolab and its customers by embedding sustainability thought leadership into innovation management, product offerings, and standardization of sustainable growth benchmarks.
Thank you, and thank you for the opportunity to speak. I guess good news and bad news about being the last panelist. I really appreciate and agree with most all of the comments from the panelists, and so I don't have a lot left to say, but I guess first, Ecolab has had the opportunity to be involved with the CLiCC project pretty much from the beginning, and had the opportunity to attend in person at the beautiful Britain Center, the couple of the summit meetings. So I'm just thinking, and you flashed the picture of the project team way too fast for me, because I was looking at the faces and, just so excited for you guys to come to this point. I really understand all of the hard work, and I was so excited also to see Jess won an award for all of her hard work. So I think, everybody should know that this is truly an exciting day, and, I just like to, as I had the chance to be face-to-face with this group, I was really impressed with, number one, the skills that the Xiaoying Zhou brought to bear on this problem of, data analysis gaps. Tons of expertise. But I think what impressed me the most was the dedication. I mean, this is a hard slog. It's breaking new ground. One of the things they wanted me to comment on was the timeliness. And as I was thinking about how do you comment on the timeliness in the context that this is a leadership project, it's something that's never been done. So it's hard, we needed it years ago, really. But I think it's very timely to use AI to bring to bear all the information that's available, but hasn't been, as somebody said, one-stop shop. So I think this is really, it's a hard project for the students and researchers, in that, you don't get the recognition because you are breaking new ground. You're, plowing territory. It will be really exciting to see how this moves forward and gets acceptance. So how was Ecolab? Why were we part of this? We're much more on the practical side. How can this information be used to support our day-to-day activities? And so my role is to integrate sustainability into the product development process. And to do that, we really need to have the best possible information about the ingredients that we select in developing our products. So, of course, we rely on folks like Dow, one of our key suppliers. And so very happy that they are also using this tool. But we need to understand, the background of some of the key chemicals that we don't have a lot of information on, and understand how their selection stacks up and what other options are. So we also participated, and the reason the face-to-face I think was so important is wanted to bring the practical perspective. How could this be used? And one of the first places that I anticipate Ecolab will use it is in even SBS authoring, understanding where we have newer chemicals, making sure that we're giving the customer the best and most appropriate information in our safety data sheet. So I'm looking at not only using this as product selection, ingredient selection, and helping our research associates make the best possible decision, but also in making the best possible communications about our products to our customers. So I'll be very interested to see how this evolves, and really encourage everybody on the phone to, I know, since it is new, it takes time and energy to learn, but I encourage, and I'm going to encourage folks within Ecolab to learn how to use the tool and see, I think it'll be exciting to see how we can leverage it. So the last thing that, they kind of asked a comment on is, how would I like to see it evolve? And right now, it's focused on, individual substances, pure substances. I'm interested to see, and, I feel a little pain to put this because it's so much work has got it to where it is now, but I, of course, and I think the team knows that, would like to see how it could be used to characterize complex mixtures in a life cycle assessment context. So that is really appreciate the opportunity to express my perspective and Ecolab's perspective, and appreciated the opportunity to meet this fantastic group of researchers and students. And again, I'm just so excited that the launch day has come, and congratulations. And I'll hand it over to Elise.
Thank you so much, Lynn. I think I speak on behalf of the entire team when I say that we're so grateful to have had such amazing partners with us through this process. We really couldn't, make an attempt to meet your needs without you communicating them with us so well and being with us every step of the way.